Let's have a look now at how many points two polynomials need to share before we can confirm that they are actually the same polynomial, or they are identically equal. Well, if we say that p of x and q of x both have a degree of whatever it is, let's say n, then they have to share n plus 1 points to be considered the same polynomial. Now this makes sense. Two straight lines have got degree 1. So if you've got two lines that are sharing any 2 points, and there's straight lines here, we should write that, linear graphs, I guess that takes into account that they're straight. If they're sharing 2 points, they're the same line. If two parabolas are sharing 3 points, they are the same parabola. And if two cubic curves are sharing 4 points, or more obviously, then they are in fact the same cubic curve. We can also say then that if two polynomials are identically equal, in other words, they're the same polynomial, then their coefficients must be equal. So you'll quite often see HSC questions where you've got one polynomial that's factorised and one that isn't. And if you know something about how many points they share and can reason that they are identically equal, then you can equate their coefficients because they must actually be the same.
So now let's look at an example where we can use that knowledge. We have to find a, b, c and d if we've got x cubed minus x equal to all of this. Now this is a really long expression and it says that it's equal for at least 4 values of x. Now why would they have told us this clue unless we needed to use that somehow? Well, if they're the same for at least 4 values of x, then a quick inspection of both sides tells me that if I was to graph y equals all of this side and y equals all of this side, what I'd have is 2 cubic curves. And I can tell because the highest power of x here is x cubed, and the same over here. So if I've got a cubic curve and they are equal for at least 4 different points on those curves, then they are in fact the exact same cubic curve. So that clue tells me that even though there's no y's in the question, I can go ahead and equate the coefficients because these things are equal. So again, it's a little confusing. We're not actually talking about curves here. We're bringing that two-dimensional understanding of y equals a cubic curve in so that we can understand how to use that clue to solve problems. So I think we could expand this whole side here and then we could equate all of the coefficients, and in some questions that will be the best way to go. This one looks like a whole lot of work expanding all of that, so I'm keen to look for some other shortcuts. I can see quite quickly and easily that the highest power of x is x cubed, and in fact the leading coefficient on this side is 1, and over here the leading coefficient, the coefficient of x cubed, would be a. So I can see straight away that a equals 1, so I've got that. So I can sort of make it better by putting that in, I suppose. Next thing to do, I think, is probably just to make some sensible substitutions for x. Now, by sensible, I mean something that's going to make things come out sort of nicely. So I can see all these x minus 2's in here. I'm straight away thinking, well, what if x was 2? Let's let x be 2 and see what happens. Well, on the left-hand side, we've got 2 cubed, which is 8, minus 2. So we get 6 is equal to, now if we've got 2 minus 2 here, this will be 0 cubed. So we've got nothing here. Again, we're going to have nothing here, and nothing here. We're just going to end up with d. So we've found that d equals 6. So we've got 2 of our solutions already. Now we just need to find b and c. So let's continue with this method. Let's let x be something else that seems sort of sensible. What about something like 0? I mean, anything will work, but we're trying to make our lives easy here. So if I let x equal 0, I can see that the left-hand side is going to be 0 minus 0. That's nice and neat. The right-hand side, I'm going to have in all of these sets of brackets just 0 minus 2. So I'm going to have negative 2. I'm going to cube negative 2 to get minus 8 here, and I'll have minus 8 times a. But I already know that a is 1. So negative 8 times 1, I've just got negative 8 there. Here I'll have negative 2 squared. That's 4. So I've got 4b. Here I'll have negative 2 times c, so that gives me minus 2c. And here I've got my plus d, but I already know what that is. It's 6. Now I can tidy up and say I've got negative 8 plus 6, that's minus 2. So minus 2, I could add 2 to both sides here, which would bring the 2 over to here, and I'll just be left with this part. So I'm going to write my equation out nice and neatly. 4b minus 2c is going to equal 2. Does that make sense? I've done a couple of things with the numbers there in my head. I've got negative 2 on this side, so I've added 2 to both sides to get the 2 over there, and the 4b minus 2c here, and then I've just swapped sides. So I've got something of a little equation. Now I can't solve that any better because it's got 2 unknowns in it. But in fact, having another closer look at it, I can see that I could make it better. I could actually just halve all of the terms. If I halve everything on this side and everything on this side, it's still going to be equal, isn't it? I've just halved everything on both sides. So that looks a little bit neater to me and easier. Now, I've let x equal 2. I've let it equal 0. Let's find something else that it could be. How about something like 1? That seems pretty straightforward. On this side, we're just going to have 1 cubed minus 1. 1 minus 1 is 0. That's good. And on this side, every one of these sets of brackets is 1 minus 2. That's negative 1. That's nice and easy to work with. So if I cube my negative 1, I got negative 1 times a, which is 1. I'm just going to have negative 1 as that first term. Here I'll have negative 1 squared. That's 1. So I'll have 1 lot of b. Here I've got negative 1 times c. So I've just got minus c. And here I've got my plus d, which is plus 6. So tidying this up, minus 1 plus 6 gives me 5 on this side. But if I take 5 away from both sides, I'll get a negative 5 over there and just my b minus c here. I'm going to write them around that way. b minus c is going to equal negative 5. Now I've got two equations. Let's call this one number 1 and number 2. I can solve them simultaneously, can't I? Now I think the elimination method would be easiest here because I can see I've got negative c on both of them. So if you've got the exact same term in two of your linear equations that you're solving simultaneously, you can just add the equations, you can subtract the equations. You would add them if the signs are different. These signs are the same. So I need to subtract them. So I'll just do one minus the other. So let's do equation 1 minus equation 2. And that means 2b minus b, that gives us b. That's worked out well. And 1 minus 5, that's 1 plus 5, that's 6. So now I've found another one of my solutions. B is 6. And subbing it into either of these doesn't matter. Sub into 2. I can say that 6 minus c is negative 5. So subtracting 6, I get c must be 11, because 6 minus 11 is negative 5. So I've found my a, my b, my c, and my d. I can write those all out nice and neatly. A is 1, b is, 6, c is 11, and d is also 6. Those are my solutions. Now, with a question like this, if you're feeling stuck, the way to go is just to start doing something. And you'll find that as you uncover more and more facts, you'll get more and more clues for how to uncover the others. Equating coefficients is something you could have done right from the start. If you wanted to expand this whole thing out, take a little bit of time, but then when you gather up each term, you could say, well, I need to have 1 lot of x cubed, so whatever was equal to that on the other side would be 1. You wouldn't have any x squareds. You'd have negative 1 lots of x, and you wouldn't have any constants, so you'd equate the two. But either way, you're going to end up with simultaneous equations in a question like this anyway. So I think subbing in is a good little skill to keep in mind when you're solving anything with unknowns. If you know it works for at least 4 values of x, then that was our clue that it must work for all values of x. And we wouldn't have known that unless we were able to reason that two cubic curves must be, in fact, the same cubic curve if they have equal values for at least 4 values of x.